Hello my friends, this is Ashkan, and in today's video, I'm going to give you the ASME B31.3 explanations on impact testing in simple words. As you probably watched my previous video on impact testing, we answered when impact testing is a must, not an option. But today, we are going to find out what is the impact testing method and its acceptance criteria. Give some time to me and let's find the answer together. But before that, please like the video and subscribe my channel. This is valuable for me. Thank you guys. Okay, first, let's talk about the method of impact testing. One important note is that the basic standard for impact testing is ASTM B31.3. If your material is one of the materials listed in this table, that referred material specification requirements shall also be met as well. To find the procedure of impact testing, we need to understand this table. Table 323.3.1 mentions the impact testing requirements for metals and is divided into 2 rows and 2 columns. The first column talks about the materials tested by the manufacturer. For example, large sizes welded pipes or the materials that are required to be impact tested on their weld zone based on what we learned in previous video in table 323.3.2. The second column, on the other hand, has focused on the materials which are not tested by the manufacturer or are even tested but requires heat treatment after site fabrication and erection. In this case, we need to use the information mentioned under this column. As an example, consider that you have a 25mm thickness ASTM 333 pipe that is going to be used in a H2S containing service. To prevent residual stresses inside the pipe thickness, post-weld heat treatment is usually performed after welding. In this case, we know that the impact testing is performed on the material by the manufacturer. But the impact testing must be repeated since the post-weld heat treatment or PWHT is applied on our material. The first row, as you can see, gives a specification on base materials testing, while the second row focuses on the testing of the welding zone. Now, after having an overall view of this table, let's get deeper into it. In each row, the table is talking about the number of the test location, and also the person in charge for performing the test. For example, section A1 tells us if we have a sample with condition mentioned in column A, the number of the test will be specified by that material specification or the applicable specification mentioned in the red box, whichever is higher. For example, if we have a ASTM A106 material that must be impact tested based on what ruled out in table 323.2.2, assume that the material design temperature is minus 30 degrees centigrade. In this case, either ASTM A106 or its applicable material specification for pipe, which is ASTM A333 here, must be followed for the number of the tests. As the ASTM A106 doesn't necessitate the application of impact testing, ASTM A333 must be followed for the number of the tests since it has greater number of test specimens. Have it in your mind that Material Man's doesn't usually use ASTM A106 in the minimum design temperatures below minus 29 degrees centigrade, since it is not appropriate for low temperatures, and the mentioned case is just an example. Please like the video and tap the subscribe button, and let's continue the video. Okay, box B1 describes that if in the previous case the manufacturer didn't perform the impact testing, or he did, but a heat treatment is performed on the sample, the number of impact test specimens must be determined based on what is mentioned in the applicable material specification, which are specified for fitting, forging, casting, pipe, and etc. here on the bottom right of the slide. Box B2 of the table tells us that if your case is any of column A or B, for the base material testing, your sample must be tested based on the orientations and locations specified in the specifications listed in the red box on the right. Box 3 is clear, but box 4 of the table describes that if you are making a WPS for your project and any of the scenarios of column A or B are happening, at least one impact testing specimen must be prepared for each sheet of your WPS. If the filler, flux, or any considerable item is altered in your welding, one specimen for each of them must be prepared. Don't forget that the heat treatment of the PQR samples must be exactly same as your actual heat treating condition during the project. Box A5 specifies the number of the test pieces for testing of the welds stated in column A. You can pause the video, read the notes exactly, and subscribe my channel, then continue listening to my explanations. This section says what you need is testing the materials for each thickness range of T divided by 2 to T plus 6 millimeters. For example, if your material thickness is 10 millimeters, you would need a test piece for the range of 5 millimeters to 16 millimeters. 5 is equal to half of the thickness and is our lower range, and 16 is equal to thickness plus 6 and stands as the upper limit. In note B, it says you don't have to test every single piece of the material from every batch, or even every material from the same job, as long as 1. Welds are tested, 2. Material is similar, and finally, thickness is consistent. Box B1 says for testing of the materials under column B, you need to categorize the materials by their specification and grade. Then you need to test one piece from each batch. If those materials were tested based on what was mentioned in section B1 and the requirements of section A5 were met, then testing is not required. To save time, let's pass this table. If you had any problem understanding this table, you can comment your question and I will reply. Before going on, please like the video and subscribe my channel. Thank you, my friends. In the section 323.3.3, the code talks about the dimension of the specimens. Accordingly, all impact tests shall be made using standard 10mm square cross-section Sharpie V-notch specimen bars, except when the material shape or thickness doesn't permit. 3 specimens at least must be provided for the test. Now let's move to the section where the code specifies the test temperature in section 323.3.4. For the selection of impact test temperature, 2 scenarios might happen. At the first scenario, which is highlighted by red, inside the table, the material's thickness is equal or above 10 mm. Under this condition, if the width of the sample along the notch is 8 mm or above, no temperature reduction in test temperature is applied, which means the test temperature is still equal to minimum design temperature. On the other hand, if the highest obtainable width of the sample is below 8 mm, the temperature reduction on the right column must be followed. In this case, we find the width of our sample from the left column, then the corresponding temperature reduction is found. By subtracting the quantity found on the table from the minimum design temperature, the test temperature is found. As an example, assume that the thickness of our sample is 12 mm and its width is equal to 6 mm. 12 is greater than 10, so scenario 1 is prevailing. The width is 6 mm and the temperature reduction would be 8.7 degrees centigrade. Assume that the minimum design temperature is minus 50 degrees centigrade. So the test temperature would be minus 50 degrees centigrade subtracted by 8.3, which equals to minus 58.3 degrees centigrade. At the second scenario, which is highlighted by blue, the material thickness is below 10 mm. Under this condition, if the width of the sample along the notch is higher than 80% of the material thickness, no temperature reduction in test temperature is applied, which means the test temperature is still equal to minimum design temperature. On the other hand, if the highest obtainable width of the sample is below 80% of the material thickness, we need to find the temperature reduction corresponding to material thickness. Then to find the temperature reduction corresponding to material width, the difference between these two quantities would be the final quantity that must be subtracted from our material minimum design temperature. Let's solve an example. Assume that the thickness of our sample is 7.5 mm and its width is equal to 5 mm. 80% of 7.5 mm is equal to 6, and the width of the sample is below 6 mm. So find the temperature reduction for 7.5 mm, then find the temperature reduction for 5 mm, calculate the difference between these two numbers, and the final test temperature would be the minimum design temperature minus the difference quantity. Another important section of impact testing is its acceptance criteria, and the first part in this matter is minimum energy requirements. As you can see in table 323.3.5, the minimum absorbed energy for carbon steel and low alloy steel materials with UTS below 95 ksi is specified in this table. Reading of this table is not complicated. It is divided into some rows based on the material UTS and some columns based on the manufacturing process of the material. For example, let's find the minimum absorbed energy for a specimen of API 5L grade X52, which has a 10 mm thickness and 7 mm width along the notch. As you can see from table A1 of this code, X52 grade material has 66 ksi UTS and it is fully deoxidized or killed carbon steel. So we need to use the second row and the first column for having the minimum absorbed energy of this material. But these quantities in the red box are not final numbers that we need to check. According to note 2 of this table, if your sample's width along the notch is below and not higher than the standard size of 10 mm, the minimum energy is calculated based on this formula. In this case, as an example, our specimen's width along the notch is 7 mm and the standard size is 10 mm. So 20 joules multiplied by 0.7 would be 14. And this is the minimum required energy for the average of 3 specimens. Accordingly, 16 joules multiplied by 0.7 would be 11.2 joules, which is the minimum acceptable amount of energy to be absorbed by one specimen during impact testing. The second subsection of impact testing acceptance criteria is the lateral expansion. As you can see, when a brittle fracture happens, the specimen dimensions are almost unchanged. But during the ductile fractures, some deformations happen inside the sample. According to what the code says, all the materials with UTS over 95 ksi, all high alloyed steel materials, and all bolting materials shall have lateral expansion not less than 0.38 mm. The third item that the code discusses is the acceptance criteria of weld impact test. In summary, it says if two materials with different impact testing acceptance criteria are welded, we have to specify the UTS of the weld zone. Then by comparing the UTS of the weld with two adjacent base metals, we will use the impact testing acceptance criteria of the weld zone material equal to the material which has the closest UTS to the weld UTS. The final section of the code talks about retesting. Based on this section, except some cases, retesting is not allowed. You can go to the section 323.3.5 and read all the combination of conditions where a retest is permitted by the code. However, some of them are listed here. For example, one of the cases where retesting is allowed is when there is an uncertainty in test procedure. Secondly, when your single specimen couldn't reach the minimum absorbed energy during the impact testing, but the average absorbed energy has passed the criteria. Thirdly, when the lateral expansion of your single specimen is below 0.38 mm but not less than 1/4 of a millimeter, and the average lateral expansion of your 3 specimens is above 0.38 mm, and some other circumstances that you can read from the code. This was the second section of impact testing we talked about. Hope to be useful for all you guys who are looking for a simplified explanations of the ASME B31.3 over impact testing. I try to present all I know and understand from piping world. Thank you everyone for liking my video and subscribing my channel. And bye bye.